Hi guys, so this is the second session of logarithms. In the last session, which is the introduction, we have seen what is the meaning of a logarithm, what is the definition of a logarithm, and basically how do we convert exponential form to the logarithmic form. We have also seen the graphs of basic logarithm. In today's class, we are going to talk about the formulae which define logarithms, or the formulae which we are going to use quite a bit under the topic of logarithms. Right, and this class or these set of formulae are the complete foundation or the building blocks of your logarithms topic, because every question in logarithms will utilize one or more of these formulae. In other words, friends, if you do not remember the formulae, the topic is dead to you. If you want to be good in topic, you have to be very comfortable in manipulation of the formula that we're going to see, understanding quickly, thinking which formula should you apply when and where to solve questions, right? So let's quickly move on to the formulae. Now, first couple of small points about logarithms. The first point is logarithm of 1 to any valid base is always 0, and we have also seen this in the graph. If you remember, the graph of logarithm when base is greater, when the base is greater than 1 was like this. For base b greater than 1, this was the graph, and this is x equal to 1. Okay, so when you have log x base b at x equal to 1, you will be having the answer output as 0. Okay, that is for any base, right? Even if the graph, if you remember the graph of base b less than 1 but greater than 0, here also at x equal to 1, you had your answer becoming equal to 0. So log of 1 to any base is always 0, right? The next is log of a number to the same base is 1, because the question is a to the power of what gives you a? A to the power of 1 only gives you a. That is the way in which we discuss logarithms, right? Similarly, b to the power of what gives you 1? B to the power of 0 gives you 1. That is why the answer is 0. Here, a to the power of what gives you 1? That what should become 1 itself. So logarithm of a number to the same base is always equal to 1. These are two basic properties of logarithms. Having understood this, let's move on to the formulae of logarithm. The first one is called as the product law or the product formula. And the formula goes somewhat like this. When you are adding two logarithms, log of a to the base b plus log of c to the base b. Now please keep in mind the bases are same. Then this can be combined into logarithm of a into c. So this a and c which we are adding will get multiplied and coming inside the logarithm, but the base will remain the same. So the idea is all three bases will be same. Extension of this can be multiple additions. So log of, let's say, x1 base a plus log of x2 base a plus log of x3 base a, and if I do like this up to log xn to the base a, this can be written as, now all of the additions will become multiplication, single multiplication. It becomes x1, x2, x3 up to xn to the base a. So this is the application of the product law. The second formula, which one of the very basic formulas we're going to look at, is called as the ratio law. So like addition is converting into multiplication, here the subtraction will get converted into division. They're very similar laws, both of them. The addition becomes multiplication and the subtraction of logarithms become division of the numbers within the logarithm. Okay, but here you cannot use multiple things because division or subtraction is always a minus b. You can't have a minus b minus c, or if you have multiple such things. So if you have log of a to the base, or log of x1 to the base b or a, minus log x2 to the base a minus log x3 to the base a, and so on. You can write this as log of x1. Now all these negatives will become division. So it becomes x2, x3, x4, and so on to the base a. If there are two of them addition, everything else is subtraction, then x1 into x2 will come here and x2 will not be there in the denominator anymore, because all additions are in the numerator, all subtractions are going to be in the denominator, right? So that's the second basic fundamental law. The third is the power law. Now what is this power law? Again, these are the laws which we use again and again in manipulation, because logarithmic questions, 99% of the logarithm questions are about manipulation of the question given to you. I'll explain to you when we solve one or two questions, but let's look at the power law. The power law says when you have the logarithm of a base and an index, so it's logarithm of a power x to the base b, this can be written as the x can come outside, and you can write it as x into log a base b. So if I have log of 10 square base 2 or base 3 or base 4, whatever, base a, I can write it as 2 into log 10 base a. So when this 2 comes out, it becomes 2 into the log of the remaining part. Okay. We have a similar property, another power law, or it is basically root law, power law, both are the same. Instead of having a power x, if I have the root x, 1 by x will come out. This is actually, I would not call it as something different. It is the same. So effectively, whatever is here will come outside. So if it is x, it will come out as x. If it is 1 by x, it will come out as 1 by x. So you don't have to worry about a new law. But the third one here is the power law for the base, which means if I have base raised to the power x, when this x comes out, it will become 1 by x. It will become 1 by x. Now remember, the x is on the number, and if it comes out as x itself. If the x is on the base, x is in the power of base, then when this comes out, it becomes 1 by x. Okay, so this is how the power law for base written. Now when you combine these two, you get a very nice result. If you have a to the power of x and b to the power of y, both the powers can come out. X will come out as it is and y will come out as 1 by y. So when both powers come out, it becomes x by y log a to the base b. Okay, so these are few properties which you use quite regularly. Then there are another set of properties. The next is a change of base law. This is very interesting. Here the basic idea is, if you have a number like log a to the base b and somehow you don't want this base b, okay, so you can change the base if you can separate this into numerator and denominator. Now how do we separate it? You can separate it directly by writing log a and log b, but make sure that the base that you are writing here is the same for both, and it can be any base. X is any valid base. Please keep in mind, x is any valid base, which means if I give a numerical example, log of 25 to the base 5, I can write it as log 25 by log 5, and I can write any valid base here and here. So let me write it as log, I don't know, I can write 10 and 10, or I can also write log 25 to the base 6 by log 5 to the base 6. Whatever it is, I can write the same base. And this is basically called the change of base law, or splitting of number and base. Okay. The next law which we are going to look at is the inverse law. And the inverse law says that if you have log a to the base b, you can also write it as 1 by log. When you take 1 by, your b and a positions will interchange. So if I have log 10 base 3, I can write it as 1 by log 3 base 10. Okay, so when I want to take this into the denominator, my base and the number positions will interchange. This is the inverse law, right? The next is exponential law, which basically tells us that a to the power of log x base a. So if this base and this base are same, then the output is x itself. The output is x itself. Now, let me give you an example of what I mean. If I have 3 raised to the power of log 25 base 3. Now you can see that this base here and this base here are the same. When they are same, the answer becomes this number itself, which is 25. The answer becomes 25 itself. That is what the exponential law means. The second part of this law is again something very interesting. If I have a power log b base c, then keeping the c same, I can interchange these two and the answer will still remain the same. Which means if I have 3 raised to the power of log 5 to the base 10, I can write it as 5 to the power of log 3 to the base 10. The 10 will not change, but these two can interchange and the value will remain the same. These are all the properties that we're going to use in logarithms, friends. Now, if you want to become good in logarithms, the fundamental thing you have to remember are all these 5 or 6 laws. Because we will notice that you cannot solve a single question without understanding these laws. It's basically logarithms is one thing only, one thing and one thing only. Do you know which formula to use to manipulate and get your answer? You cannot, very rarely do you apply logic in logarithms. Most often than not, it is somehow manipulating the question given in such a way that the entire expression. So usually when you look at questions, you will have a huge equation given and you're supposed to simplify it and get the final simplified version, or they'll give you a huge equation equal to something, equal to a constant or something on the right hand side. So you will simplify this, get it in the form of log x to the base something equal to right hand side, and you'll get x equal to, let's say this is a to the power of some. This is going to be your final answer. But this conversion from here to here, or the simplification of the huge expression, that entire task is on understanding of the formula that we have seen. We will use more than one formula in conversion or simplifying your logarithmic questions. So please make sure that by the time you look at the next video, you are by-hearted, or you have by-hearted the complete set of logarithms, at least the laws that we have seen till now. Okay, thank you friends. See you in the next video. We will be covering inequalities in logarithms and questions in the next 2 videos. See you soon.